All right, I want to welcome you to the 2015 Lunar and Planetary Laboratory Fall Lecture Series. My name is Tim Swindle. I'm the director of the Lunar and Planetary Laboratory. Before we get going tonight, I just wanted to let you know about a few of the things that we have coming up that we are sponsoring. For one thing, the last of the 3 talks in this series this fall will be about 6 weeks from now, Tuesday, November 24th. It will be Dr. Christopher Hamilton talking about volcanism on Earth and Mars. Christopher does things like flying kites over lava flows in Hawaii, all sorts of cool stuff like that. Other things going on, as you came in, you may have noticed that there's a bunch of artwork out in the atrium. That normally is not an art gallery, but for 1 week out of the year, it becomes such. Really for the weekend, we have the Art of Planetary Science show, which will be Friday 5 to 9 p.m., Saturday and Sunday 1 to 5 p.m. That's this Friday, Saturday, and Sunday. It's organized by our graduate students, but has artists, professional artists, has images from our spacecraft, all sorts of great stuff out there. Other things I wanted to note, the Space Drafts, which is the more informal lecture series at Borderlands Brewery. The next one of those, have to pull up my phone to find it, is October 21st. That's next Wednesday. Dr. Theodora Carlidi, and she will be talking about rainbows on exoplanets, searching for signs of clouds and life on other worlds. Then on a very new event, first time we've ever collaborated with the Poetry Center and the University of Arizona Arboretum on an event. Good combination, right? So that's a week from, or sorry, 2 weeks from Friday, October 30th, the day before Halloween at 4:30, between this building and the Flandrau Science Center and Planetarium is a tree known as the moon tree that was grown from seeds that flew around the moon in one of the Apollo missions. And so we're just having an event to commemorate that. The featured speaker will be the son of the astronaut who carried the seeds around the moon. So you're invited for that. And finally, some things that LPL doesn't sponsor, but within the College of Science that I want to highlight, the astronomy department has their lecture series pretty much every Monday. I don't know what next Monday's is, but check that out if you like that sort of thing. And in February, the College of Science lecture series in Centennial Hall this year will be about climate change. So that should be interesting. So keep that in mind. That will be pretty much every week through February on Monday nights, plus a week or two on either side. Tonight, though, we do have a treat. Tonight's speaker is Dr. Veronica Bray. Dr. Bray got her bachelor's and master's at University College in London, and then her PhD from Imperial College London, and then decided that was enough of London and moved to the desert, came out here, where she worked as a postdoc. She is now an associate staff scientist at LPL, and this year she's been spending a lot of time being a member of the New Horizons team, and so tonight's talk will be about Pluto, up close and personal. Veronica.
Thank you. Is this okay, or do I need to speak a bit louder? Is it good? Okay. This talk will probably benefit from lower lights. I have been in here before, but if somebody who knows could lower the lights a bit for me, please. Because, of course, we're going to be getting a lot of nice imagery in this talk, though I am biased. Today's talk will be not just geology results, because they're coming back to us very, very slowly. And also there's a science paper that will be released in a couple of days' time, and it's very bad timing, I'm sorry. Just a couple of days later, and I could have told you about so much more, but the science results are embargoed until that big press release. So in order to plump the talk somewhat, I'd like to tell you also about the personal experience of being involved with the mission, at mission control during such a historic event. Okay, so I would like to kick this off with the hot topic, is Pluto a planet? And so I'll need a bit of audience participation on this. So just please raise your hand if you think that this looks like a planet. Wonderful, good. Raise your hand, please, if you think this looks like a planet. Okay, good. I should clarify, I'm not asking you whether you know whether this is a planet or not, because that's not everyone's speciality. Just whether, when you look at it, do you think planet? Okay, so this one, hands up for yes, please. This one, hands up for yes, it's a planet. Okay, a few less. Well, a lot less. Hands up for this one, if it's a planet. Ooh, shh, spoilers. Okay, don't fail me, please. Okay, so hands up for this one, if it's a planet. Ooh, there's a couple of jokers there, I think. Hands up for this. Do you think it's a planet? Oh, no, getting less and less confident as we go on. And final one, hands up if you think this looks like a planet. Okay, a few. Okay, the reason I wanted to go through that is I found that a lot of people will call one of these bodies a planet if it looks interesting. It really is that black and white. Every time I've asked people this question, if you have a basically black and white object, you get fewer hand raises. It's not interesting enough to be a planet. So out of those pictures I just showed you, these are the planets, of course, Jupiter, Earth, and Venus. The moons here, Jupiter's moon, Ganymede, it's the largest in the solar system. It's larger than the planet Mercury. Jupiter's moon, Io. These are not to scale, by the way. All of these, Jupiter is obviously a lot larger than its moons. And then these two more boring ones. Our moon, of course, we know. And then Miranda, one of Saturn's moons, you know, they're black. These two are black and white. They're boring. They're easily identifiable as not planets to most people, whereas these usually get a few more hand raises. And then, of course, people in the know recognize this as Ceres. It's a dwarf planet. And then this one down here is a bit of a trick. This is Pluto's moon, Charon. But I'm going to tell you that it's not actually its moon, technically. So Pluto and Charon, up here for scale, so against the Earth, this is how big Pluto is, and its moon, Charon. And you can see that they're almost the same size. Charon is about half the size of Pluto. And because they're that similar in size, they don't orbit around Pluto. Charon doesn't orbit around Pluto. They orbit around each other, as this cartoon shows. And so this is what we call a binary planet system. It's not, so you could call each of these are a planet. So Charon is as much a planet as Pluto is, technically. I should note that the official videos that you see from New Horizons, we show a lot of videos zooming in on the system, and it kind of flies by. We've chosen to make Pluto dead center instead of this, because otherwise it really makes your eyes hurt as you're flying by and everything's wobbling. But just so you know, this is what is actually happening. And so it's interesting for people to find out that Pluto is part of a binary planet system. It's our only binary planet system that we know of in the solar system. So the second almost trick was Ceres. Ceres is a member of the asteroid belt between Mars and Jupiter, and it was found in the very early 1800s, and it was named a planet. And for about 70 years, it was still called a planet until astronomers discovered the rest of the asteroid belt. And once they realized that instead of being a body on its own orbiting the sun, when they realized that it was actually in a belt of material, they had to declassify it as a planet. Of course, we don't know, maybe people kicked up a stink then, but to us now, a lot of people, they don't care about Ceres being demoted as a planet, because for us it never was. But that's why Pluto can also be called a dwarf planet, because it's not there on its own. It's orbiting in this vast belt, the Kuiper belt, of icy objects, similar to Pluto, although we're finding a lot of variety in the Kuiper belt. It's full of all of these different worlds that are geologically interesting in their own right. And so to spit it out, is Pluto a planet? I used to be in the camp that I would argue, no, it's not a planet, whereas now I realize that I could say it's a type of planet. It's a dwarf binary planet, but it's a planet in the same right as a pygmy hippo is a type of hippo. So here's a nice, friendly pygmy hippo. If in a bad mood, it could still do some damage, but it's not the same as a 3-ton kill-you hippo. Okay, so after getting that out of the way, New Horizons basics. New Horizon is a fantastic little spacecraft. It's about the size of a mini grand piano. We put it on the biggest rocket available at the time, the Atlas V, so a very small spacecraft with a lot of oomph behind it, which gave us a very fast exit speed. It's the fastest launch from Earth ever, and it helped us get to Pluto in just 9 years. The other helpful factors were that the Pluto was close to the Sun, and we also slingshotted the spacecraft around Jupiter to give us a gravity assist. It sped us up even further. And that speed is actually why it's a flyby. I get asked quite often, why didn't we get an orbiter? And it's simply because we're going too fast, and Pluto is too small to slow us down with its gravity. There's a lot of instruments on board which give us information about the atmosphere, solar winds, temperatures, composition. But today I'll be sticking with the imaging systems because I'm on the geology and geophysics imaging team, so we'll be sticking with just the images today. So before New Horizons, this was the best we had. This is a Hubble Space Telescope image of Pluto, and you can hopefully make out that we could see the heart here. So, and this is a gigantic leap in knowledge. The biggest that I've ever been involved with. To go from almost nothing to an obviously interesting geologic body that we can now study the surface processes. So the daytime for Pluto is 6 Earth days. So as a flyby, we're only going to image one side of Pluto. So 3 days before our closest approach, and if you see CA, it refers to closest approach. 3 days before that, we got our last look at the other side of Pluto. This is the side that faces its moon, Charon. Quite a few of us were disappointed in this. My speciality, among other things, is impact cratering. What happens when an asteroid or a comet hits a planet? And so, of course, I'm interested in the scars, the craters that are left in the surface. And one of my predictions was that we wouldn't see a particular type of impact crater called a central pit crater, which that might be, but we're never going to get the picture of it, so I can't tell. It was tantalizingly close, and so I really personally want to know what that is. So I was one of the people that were disappointed that we're never going to see this better until the next Pluto mission. Okay. As we got closer and closer and closer to Pluto, we started getting obviously better and better images. And as we drew closer, one of the first surprises was the dark polar cap on Charon. We could see this from far away. We'd see a bright white body with this dark polar cap. And that was really unusual because the Earth and Mars and other bodies, they tend to have a bright polar cap because that's where the ices will condense. And so usually that's bright white. So we were wondering why on earth is this a dark polar cap? And then when we got even closer, one of the biggest surprises for the science team was that Charon wasn't boring. It wasn't geologically dead. We were expecting impact craters upon impact craters upon impact craters just like the Earth's moon. I should note that this isn't to scale. But that's what we were expecting, was that the surface of Charon would be so old that the only time you got rid of an impact crater was when another impact occurred and erased the first crater, leaving the newer one. And so to get there and find, okay, we see impact craters, but they're on a relatively smooth plane. And we see the gigantic tectonic features, and I hope you can see here, this is topography along the rim. These are like faults and graben that we can see along the edge of Charon. And using some of the measurements of these divots in the side, we can find that there's canyon systems on Charon that are about 5 kilometers deep, so 3 miles deep. Okay, so the first of the personal slides. Closest approach was a gigantic deal. I've not been involved with anything quite so media heavy before. And I've never been involved in such a strange countdown before. We'd got somewhere close to 1,000 people there, and we were all given flags to wave. And there was a gigantic countdown, everyone shouting, 10, 9, 8, and at 0, nothing happened. Nothing, apart from flag waving. Because at that point, it wasn't we didn't have a picture to suddenly give. It was just the knowledge that at that exact moment, New Horizons was at its closest distance to Pluto. Very close. In planetary terms. I realize this is a far distance. And it was a bit nerve-wracking, even though we didn't know, if the spacecraft was having a good or a bad time of things, we wouldn't know at that point. But it was nervous enough so that I'd got my flag and I was just kind of rolling it around in my hand. And I don't know whether this is a deliberate crop. I'm on the side here, and you can see that you can't see my flag, because when it became time to wave, it was tightly wound around the stick, and it looks very silly. And you don't want to spoil a picture of the Planetary Science Division chief for NASA with a strange, stunted flag on the side. But it was very strange. There were celebrities, so many media taking photos. If you were wearing a team shirt, you'd get stopped and just asked questions, that was fantastic. And that's part of the job of a scientist, is the public outreach, being able to talk to people about this. But the fangirl, I made sure to get my picture with Bill Nye, the science guy, and I was actually quite amazed that we all queued up to talk to him, but then he kept us talking to him for 10 minutes. He wouldn't let us go. And it was then that a few of us realized what we were involved in. That the fact that the celebrities were wanting to talk to us on that particular day helped us to remember what a historical event we were being part of. So even though there was flag waving and a lot of fanfare, the bigger event was call home. So this was about 13 hours later, when New Horizons would signal back to Earth. Oh, sorry, I get ahead of myself. I should say that the reason there were those 13 hours with nothing in between was because the New Horizons spacecraft had to turn away from Earth. It stopped communicating with us so that it could concentrate on its science. Image, 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 taking all of the data it could. And this was a pre-programmed sequence. And so this is the Mission Operations Center, and you can see it's empty, apart from this lone janitor vacuuming. I don't know, honestly, I don't know whether this was planned for comedy's sake, but some of the news coverage, they went to the live feed from the operations center, and all they saw was this. So, planned joke or not, that did get a huge laugh at the time. So this is the trajectory. So we stopped communicating with the spacecraft. It then goes into the Pluto-Charon system. And you can see these are the orbits of Pluto in the center and its moons. So we didn't hear anything. It just concentrated on imaging, crossed through the orbits of Pluto and Charon, and then it would, at this point, this is the occultation, it turned back round to take a picture of Pluto from behind with the sun illuminating it, and then again it did that for Charon, and then only after it had completed its imaging campaign would it turn back to Earth and send us a signal that it had survived. Now, I use the word survived very carefully. If you're crossing through the plane of all of these moons, we didn't know for certain whether there was debris in there. Was the spacecraft going to hit anything that would end it? And I can't speak for anyone else, but I know that until that day, until I was standing there checking my watch, like 1 minute before, I hadn't even considered the possibility of failure. And it was only when we were waiting for call home that I realized there wasn't any point coming into the office the next morning if we didn't get that ping back from the spacecraft. And so this is something that a friend of mine found in an Italian online newspaper. I think that's 9:01, call home came at about 9:02. And you can see the other faces just worry on the science team until we got that call home. But then, fortunately, what the buzzword you want to hear, all systems nominal. That's all you want to hear. And this picture this is the more popular one. I've seen this in several newspapers, and there were several different photographers getting this from different angles, because this is the NASA spokesperson, Dwayne Brown, very big personality. You know you're going to get a good response from him if all goes well. So they were primed, ready to take a picture. And in almost every photo, regardless of angle, it looks like he's punching me in the face. Can't help it. But so this is about 5 seconds later, and that's just relief. Because then we could start getting towards the new images, not just images, like I said, just the new data coming at us. If we hadn't made it through, this would have been the last that we had, the best image. Still very, very good, but we had a treasure trove of high-resolution data coming back to us. So this is our glorious leader, not Alan Stern, the leader of New Horizons, but this is Jeff Moore, the leader of the Geology and Geophysics investigation team, and he's showing us the different high-resolution images that will come down. So this is the sphere of Pluto. You can see the heart here, Tombaugh Regio, and then these little boxes here are our high-resolution data. And the red one here was one of the first that was going to come down. And it was actually quite disappointing, because to us it looked like it was just going to be bright white, featureless ice, basically. And we couldn't pre-plan this. Whatever face Pluto was showing to us when we fly by, that's what we were going to get. So we came in with a bit of excitement, but not expecting much the next day. And yeah, it was amazing to just see these strange polygonal shapes and strange, like these are actually very large figures. Very large features. So like hills and mountains poking up from between the polygons. There's even you possibly can't see it because of the desk, a wind streak down here. So here's a close-up. Yes, definitely. We were not expecting to see this much interesting features on what we thought was going to be a plain ice sheet, effectively. And the first thing that struck us, if I back up, there are no impact craters. And so although I have other specialities, the primary reason I was brought on board was to analyze impact craters. So there were a few jokes made that morning about how I could just go home. But fortunately, I'm involved with a couple of other missions, and I'm used to looking at like the polar caps of Mars. And so some of what I was seeing was reminiscent of what we see on the polar caps of Mars. So we see these possible like sublimation pits, within these polygons. And then the question, why are those polygons there? Are they contraction cracks like we see on Mars? The party line at the moment is that our favorite theory is that they're actually the top of convection cells, convecting nitrogen ice. So if I back up to give you, the whole view, this whole area is filled with just these convection cells. We're still not 100% sure because, of course, we only got this data down just a couple of months ago, so we're still working and taking measurements to test our current hypothesis. You can also see a possible wind streak here from that dark pit. So the question when we first got the image down was, is it a wind streak? Is it some sort of geyser eruption like we see on Neptune's moon Triton? Or the funniest explanation when we had the low resolution images was maybe it was a JPEG artifact. And it wasn't in fact there, it was just smearing on the image. But now that we've got this high resolution image back, we think that they're real. So we think they're wind streaks. And just to give you an idea, this image is about 120 kilometers across. Okay. Sorry?
Where is this little part on the bigger one?
Ah. Oh, sorry, I can't get the hang of which direction I'm going. So this, I think I've poorly chosen something off to the side here, because I wanted to get a wind streak in, and then also show you that the cracks between the polygons, sometimes they have central ridges. So this is one of the good examples. And for scale, this is about 2 to 3 kilometers across. So this is a huge hill/mountain. Okay, so that section of data was just here. Oh, there you go. That's the last image. Okay, so after getting an image back of this and being utterly surprised by it, the next day we came in awaiting the arrival of the next close-up image. And there was a bit of a feeling that it couldn't get any better, it couldn't get any more surprising. And so when we saw this, I've never known so many big personalities to be quiet all at the same time. And there was just an awed, respectful silence, and everyone was just looking at this image for a while. To me, it looks like, I'm not suggesting this is what's happening, but to me it reminded me of satellite pictures of coastlines here on Earth, where you see the land up here, rugged terrain, and then you see swirls of, in the ocean's case, different sediments, the brighter greens and the darker blues of this sea, whereas in this case, what's happening is we have rugged cratered terrain. So here's a degraded crater. There's another one here. And we think that this is nitrogen ice flowing around. Now when I say flow, not over the course of a day, years, thousands of years, for this glacial type flow. And so we can see it even breaking into a very subdued, degraded impact crater here, and it just starts filling in. So we think that this flowing nitrogen ice is coming from the center of Sputnik Planum and kind of embaying all of this upland terrain. So, like I said, there were a lot of photographers. Fortunately, they kept all of the media in the media building, and then we could go back to our own government-controlled building to do our science. But they did allow some photographers in to try and capture the moment. And accidentally, we gave them a lot of opportunity for good group photos. And I think it's enthusiasm/laziness on our part. because each one of us could have accessed the image that we're looking at. But it never happened. Even though each of our computers were linked up to the central system, whenever one person got the image down, everyone would just not spend 5 seconds bringing it up on their own computer. We'd just all leap up and we'd look at that one screen together. And after a few oohs and ahs, there'd then be the science discussion. Well, what's that bit that we're seeing here? What's that? And the one person in this photo that knows there's a camera is this guy. This we learned after a few photos got circulated to the group that this is his scientist look. It's like, I know that I'm being photographed. I was having a conversation, so that's my action science shot. Although, if you don't mind the phrase, I did discover during this mission with all of the photos that I do suffer from resting bitch face. And there's so many brilliant group photos, and a lot of us just look really moody. I mean, Kelsey there is very, very happy to be looking at images of Pluto, but she, yeah, we didn't know how to show that for the cameras, and we personally weren't thinking about that. But this is one of the well-publicized images, because look how perfect it is. Smiles, and then the hand on the PI, Alan Stern. This was our embedded journalist, so he wasn't on the science team as such, but he stayed with us for a couple of years working with the science team. And he, because he's a bit more media savvy, I think he realized that there was a nice tight group of smiling people, and that would just make it perfect. So, okay. For those of you that are Queen fans, they also brought on board Brian May, the guitarist of Queen. He does have a PhD in astrophysics, and so he came along and hung out with us for a couple of days. So then, of course, there were a lot more photographers allowed in, and this is, I like this photo because this is us showing him, like linking him up to the computer system and showing him the Pluto images on his own computer. Okay, so a personal slide. There were a lot of odd hours, and back in July, my newly born daughter was 4 months old at the time, and so coming into the closest approach 2 weeks, I was really certain that I had the sleep deprivation thing down, and that we had training emails about how to not suffer from sleep deprivation as badly, and I ignored all of them because I thought I was used to it. But because the images were coming down at all different times of the day and night, people were up processing the images and analyzing them at all times of day. And so we did start to become a little strange at the end of the 2 weeks. So this one I think is actually quite convincing. Yeah, you've got the ears here, the eyes, the nose, and the tongue. So when somebody said that they'd found Pluto on Pluto, we did think they were being a bit silly, but yeah, we all saw it. And I wanted to include this slide so that I could just try and voice how friendly it and how high the morale was on the team. Even though everyone was sleep deprived, I didn't hear any arguments. What I did hear was a lot of strange, sudden Blazing Saddles or Monty Python quotes. Like the room would be silent and somebody would just yell out one line, and then the rest of us would start joining in, and we'd kind of work through one of the sketches while working. And even at one, I think it was at 2 a.m. one night, we had an impromptu round of row, row, row your boat. Just enough to keep you sane. And if you wanted physical exercise during the wee hours of the night, you could get up and steal a mascot and go and hide them somewhere around the building. This was a ransom note we received in our room saying that if the penguin is safe for now and if we wanted to see him again, bring gin and tonics to the composition room. So it was, yeah, the morale was exceptionally high and everyone was very friendly, I thought. One of my attempts to have a break during a hard working day was this. I put my water bottle on top of a published Pluto image so that I wouldn't get in trouble leaking new data. And I was going to put it on social media that I found water on Pluto. But that morning, the composition team had found water on Pluto. So I didn't dare put this up as a joke, just in case. But because it was a big result, we were expecting water ice on Pluto. Because we know that it has a rocky core, a water ice mantle. But as the spacecraft got closer and closer, the composition team, they were looking for water and we didn't see any signal of it. So that was starting to be the question, where is the water? And so if you can't get it spectrally, if you can't see the composition, you can still infer it by looking at the landforms that we see on the surface. And that's because at these temperatures on Pluto, so this is exceptionally cold, about minus 400 Fahrenheit. Water ice is as hard as a rock at these temperatures. And so you can get very large mountains. But with nitrogen ice and the other ices that we were seeing on Pluto, it's too weak to support large topography. So we knew if the high-resolution images showed us large mountain structures, then we're probably looking at water ice. And so we did see them. This is one of the first high-resolution images back. So the region that I showed you before is just to the north here. And these are very large mountains. So I think 2 to 3 kilometers high, if memory serves. Oh, sorry, I mean 11,000-foot mountains. So nitrogen ice couldn't support that topography. It would just kind of sink back into itself. And so we know that these are probably created of water ice. But that brings up another question. We're not seeing any craters here either. Again, with the jokes about how I can go home. But if there's a lack of craters, it means that this surface has been exposed to space for a relatively short time. See, craters on a planetary surface are like the number of bugs that you get on your windshield on a long drive. The longer you're on the road, the more insects will hit your windshield. So if a planetary body has been exposed to space, it will eventually get more and more craters on it. So the fact that there are large mountains means that there's some sort of force driving mountain building. The fact that there aren't craters means that there's something resurfacing the surface of Pluto. And so this is still a science question that I haven't heard a good answer to from the team yet. It's driven by an internal heat source. What heat source? I mean, all bodies in the solar system, when they accreted, they will have accreted radioactive material, and that would heat the inside and provide a heat flow. But Pluto is so small that the estimates are that that heat source will have been used up by now. And so the question is, what is the heat source? Why is Pluto so active compared to what we were imagining? Okay, so last week there was another press conference to confirm the presence of water ice, this time from the composition team. So we're not inferring it anymore, we have found it. And so this is an image of the limb of Pluto, and with Sputnik Planum here. I should say that Sputnik Planum is the thicker ice side of Tombaugh Regio. So Tombaugh Regio is the heart. Sputnik Planum is this lobe of the heart. And the ice that we found was just here. So we now have spectral data that shows us that these mountains on the side of Sputnik Planum are water ice. So here's a zoomed in shot. all of these are like tilted ice blocks. I wouldn't say icebergs because these are a mountain in their own right, like Mount Lemon-ish. And we think that all of these are tilted water blocks. So you can also see here that this is the exposed ice side, and this was the top. So the whole thing got covered in this reddish material and then tilted to expose the fresher ice. So this is where we're seeing the water ice signature. And just for interest, here is a confined glacier up here. The same sort of material as we see in Sputnik Planum. Okay, so one of the questions of this area was why does it appear red? Like, is water ice for some reason red? Is there an impurity in it? Or is it covered with a coating of red material? And I think a lot of you will agree that it looks like it's a coating. The upper surface is being coated with red material for some reason. And what we think this is are tholins. Now, tholins is a class of organic molecule. It's created when sunlight breaks down nitrogen and other ices, and it creates these organic compounds that can range in color from a dark yellow to a dark red. And so we think that this is what the dark red of Cthulhu Regio here is, and that's what we also think the polar cap is. We don't know whether the polar cap of Charon is red because that's where the tholins form on Charon, or maybe for some reason there was an ejected material from Pluto that happened to hit the pole of Charon. That's still up for discussion. But before I finish, I wanted to touch on I'm sorry, I know I've run over time. I wanted to touch on some of the composition. We know that the middle of Sputnik Planum has got carbon dioxide convecting ice and then convecting nitrogen ice with methane also in the mix. The polar cap here is nitrogen and methane ice, and that some areas are methane poor. So what's next for New Horizons and the science team? This was the last image taken of Pluto, looking back with the sun behind it. But it's not the last image that we're going to receive. The data on, see, this makes me laugh. The data from closest approach is stored on board on a computer that is less advanced than the smartphone that you have on you. It's on a pair of 32 gigabyte hard drives, and it's coming back to us really slowly, 1 to 2 kilobits per second. Your internet at home is probably about 100 megabytes per second. So this is trickling back to us over the course of the next year. But in the meantime, we're really getting as much data out of these images as possible. So even where we think there's no data, we zoomed in and we saw this. So here you have the haze layers. No one was expecting layered atmosphere. And so we see this haze layers in the atmosphere, and then this wonderful mountainous region and all of this flowing glacier systems. And so this will be spoken about more in a science paper that's coming out in the next couple of days. And the mission is really trying hard to get all of the images out there to the public as fast as possible. And so with that, I'll leave you with one of the addresses that you should check for the most up-to-date images. And thank you very much for having me.
We do have time for a few questions, and before questions, a couple of things. If you want to ask a question, raise your hand. We do have some microphones. This is being recorded, so please wait until you get a microphone. And the other thing is, if you are a student and need to have your notes stamped, there will be, at the end of the Q&A, we'll have somebody up at the front and somebody back in the atrium who will be stamping notes. So questions? Down here in front. Wait for a microphone, please.
Given the chemicals that you described, methane, nitrogen, so on and so forth, any possibility that you may find more complex compounds such as amino acids or things like that on Pluto?
I'd say that there's the possibility that they are there, because we know that we do find amino acids on, or complex molecules on comets and other basic bodies. So I'd say there's a good chance that they're there. However, I must admit, I don't know whether the spectrometers are ready to find them, like whether we could identify complex compounds like that.
At 40 degrees Kelvin, is it really possible that the ice glaciers could be flowing?
Yes, that's the morphology that we see really does tell us that they're flowing in and embaying. Like we see the flow margins in some areas as well. It's down here. Oh yes, but this is nitrogen ice. So even at those temperatures, it's still quite weak, and so it can flow like ice does on Earth. So not like water, but slowly over a longer time scale.
Is it not possible that the gravitational pull of Charn is driving some of the tectonic forces?
Possibly. I haven't heard that suggestion personally, but I'm not on that section of the team that's looking into the dynamics of that. We do know that it's not tidal. A lot of bodies get internal heat because of their moons, but Charon and Pluto, they face each other. They're tidally locked. So any tidal energy that was released into that system, we also think was gone a long time ago. So.
So first of all, congratulations to you and your team. I'd like to know, is there any composition that's on our planet that would correlate to this kind of ice and this kind of mountainous? When you were talking about ice blocks, and I thought, does Antarctica or the Arctic resemble this at all?
On a smaller scale, we can see like icebergs will carve off and tip to the side to expose, like layering. It's on a much smaller scale, primarily because on Earth, water ice, it's closer to its melting temperature, so it's much weaker. Whereas on Pluto, it's much, much stronger, as strong as rock, so it can be part of a very, very large mountain system.
Okay, then if I understood you correctly, this is a separate question. If I understood you, you said that right now the scientists believe that the gravitational pull is at its minimum, that because it has used up its core fuel. Is that correct?
Oh, the gravitational pull is still at it's constant, but we believe that it would have used up its internal heat from radioactive elements.
All right.
So like, for example, the Earth still is heated by a lot of radioactive decay at the core, but that's because we're a very large planet, so we accreted a lot more radioactive elements at the beginning of our formation.
All right, so the thermodynamics have nothing to do with gravitational pull, is that correct?
No.
Oh, all right.
Is there any information on how distance from the sun may be affecting the planet's surface?
Yes. Pluto has a complex system that we're not used to looking at for other planets, and that's because its orbit is not as circular as the rest of the planets. So it has a time very far from the sun where we think its atmosphere actually condenses on its surface. So we believe that there's nitrogen ice snows down on the surface and would form a layer. That might be one of the reasons why the impact craters we see on the surface are so degraded, because they're getting coated every year, and then, I say every year, every Pluto year, and then when it gets closer to the sun, the atmosphere then kind of sublimates off and becomes thicker, and so eroding the bedrock.
That was going to be my question. In other words, if it's really frozen nitrogen, is it possible the planet is sublimating, giving off nitrogen gas, in which case it ought to be getting smaller with time?
Yes, that's correct. We do wonder why there's so much of a nitrogen atmosphere further around the orbit than we were expecting, because we would expect that to be lost to space. So one of the questions was, how can we maintain a nitrogen atmosphere? And a lot of people think that Sputnik Planum is the source. Like there's something coming up from the inside, like bubbling up, that is releasing nitrogen, which then sublimates into the atmosphere.
Other questions? All right, then let's thank Dr. Bray again.